Okay, this next thing we want to talk about is the idea of standard form. Now, in years past, in your science class, you've probably heard of this type of form of a number referred to as scientific notation. And actually, your textbook uses that as well. But as a mathematician, we don't use the term scientific notation. We call it standard form. So, standard form is this idea of if we have a really, really big number or a really, really small number, a small decimal number, sometimes it's clunky. It's clunky to write those as a as they're written as a a really large or small number. Now, obviously, you can see I've got all sorts of technical issues going on, but we're just going to power right through it because that's what we do. For example, if I had a number like 5, 6, 7, 0, 0, 0, 0, 0, that's a big number, right? That number is so big that I'm not sure that there's a lot of value if we were going to manipulate that number or play around with it. It's so big that sometimes it gets challenging. Now, it's not that big of a number, but you could imagine even bigger numbers than that where it'd be. So what we often do is we end up rewriting this in something called standard form or scientific notation. And what that means is I want to get rid of everything except for typically the first three digits of the number. The three significant figures is what they are. A significant figure is a way of rounding, especially in the IB program that we use, where we're checking the first three non-zero numbers, and then we look at the fourth number and we decide, is it closer to what that third number is, or is it closer to another? It's just another way of rounding. You'll get used to it as we practice it. Nothing to worry about there. So if I was to look at this, what I'm going to do is I'm going to end up rewriting this number in the form where I do a times 10 to the nth power. And what that's going to do by rewriting it like that, I end up converting the number to something that's a little bit more manageable. It's faster to write. Additionally, we can do a lot of our index multiplication rules and division rules working with standard form. So what that means is I'm going to be moving the decimal. I'm going to be saying, okay, I want it to look like that. And I want A to be something like, A needs to be somewhere in between the number 1 and the number 9. So that's where we want A to be. It needs to be a 1 or a 9. So I'm going to move it so my decimal moves from here all the way to this point here. To do that, I'm going to have to move this once, twice, 3, 4, 5, 6, 7, 8, 9 spaces. So 9 spaces overall. So when I rewrite this, this is going to be 3.5. And here I'm going to do my rounding. I'm at 6. I look at the number before it. It's 7. So I'm going to rewrite this as 3.57. And then I'm going to multiply it by 10 to the 9th power. Okay? Because I had to move it forward 9 spaces, it's to the 9th power. Real quick, if I wanted to check that on my calculator, 3.57 times 10 to the 9th power, it's going to give me that in calculator notation. But if I just take this, and I press that again, we can check this again. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. That's right where it was before. Those are the same values. Now, granted, I've rounded it, so we've got that. But that's what we're looking for. That's what scientific notation or standard form does, is we take big numbers and we can turn them into something that instead of having to write 10 digits out, I can write out 9 digits. Now, this also works, as I said before, the other way. If I had a number like 0.0000005423, and a way that a number like that might come up would be through measurement. This is one of the reasons why we call it scientific notation. It's typically most commonly seen in chemistry, where we're taking a pipette and we're measuring a certain amount of liquid. Well, we could say that we're measuring, three, three drops of a liquid, and it's this much of a liter. So it's just the teeniest, tiniest amount of some liquid, and that's where we could go. That's the context. Let's turn this into standard form. Again, it's going to look like a number that's somewhere between 1 and 9. Actually, 1 and 10. I should change that up now that I'm doing this, because it is 1 and less than 10. Because it just can't be 10, but it can be 9 something. Anyway, here we go. First off, I need to move this decimal so that it is in between the 5 and the 4. That's what my goal is. So let's see how many spaces that takes. Once, twice, 3, 4, 5, 6, 7, 8 spaces. Again, I'm going to round this as I write it. So I'll do 5.4 and then 2. Again, I would look here and I would check this next number. Is that closer to 0.0000542 or 0.0000543? Well, rounding, that would give me 542. So I'd leave that at 2. I'd round that. And then I'm going to multiply by 10. And then, if we remember, we had to move it back 8 spaces. So it's going to be to the 8th. But I'm going 8 spaces back. So by going 8 spaces back, this has got to be a negative 8. And again, if I wanted to see that on my calculator, I can do that. It was 5.42 times 10 to the negative 8 power. My calculator is always helpful, and it's like, no, let's show this as what the calculator wants to do it as. Why didn't that work? For some reason, my calculator does not want to evaluate that as a negative. It doesn't want to show me that as a decimal. Yeah, I don't know why, but that's the glory of these videos. Anything could happen. There could be some strange person walking in the background. Whatever could happen, could happen. With this, I think you're dangerous enough. I think you have enough skills that you're going to do just fine on the next section. So good luck, and I hope that's helpful.